Thank you for coming to our first technical event of the year for the CIBSE VIC committee. Gregor's agreed to present on UV air and surface disinfection in HVAC systems, which we think should be a bit of a niche topic, but something that could be very interesting. So there'll be a quick welcome from myself, over to Gregor for the bulk of the presentation, and then we'll have a QA from about 6:45 to 7 onwards. If you do have any questions, just post them in the chat, and we can go through them at the time. Go through them at the end, and then we'll probably wrap up around 7:30ish, depending on how many questions we get. So before we start, I'd like to acknowledge the traditional custodians of the land from where I'm sat today, the Burrung, Boon Wurrung and Wurundjeri Woi Wurrung peoples of the Eastern Kulin Nation, and pay respects to their elders past, present and emerging, and extend that respect to any Aboriginal or Torres Strait Islander people here today. We've got a couple of quick CIBSE announcements before we dive into it. Firstly, I'm not sure if anyone's seen this or not yet, but the CPD requirements are changing for CIBSE corporate members, and this is to align with the Engineering Council and requirements for various other institutions around the world. So the crux of it is now that you can actually be audited on your CPD. So this mainly applies for anyone with membership, which is that sort of chartered level and above level of membership. There is a free webinar coming up on that, so if you are interested, there's details there, and we can share details in the chat as well. Speaking of, there's also a professional membership and registration webinar, and this is something that we run probably twice a year, and it's normally very popular. It's just a run through of how you go about getting the various grades of membership within CIBSE, what you need to do for each of those levels, and how to achieve professional engineer registration, which again is something that we're seeing more and more nowadays come through, and is becoming a strict requirement of working in the industry. That's the 10th of April for the next one of those, and then there'll probably be another one, I'd imagine, around November. We have the Young Engineers Awards coming up. Entries open from the 4th of March. So if any of you were there last year, there was a really good turnout. We had the awards night towards the end of last year. Some really good projects and works that was done there. Everyone very deserving of the prizes, and everything that came from that. The presentations were really interesting, and it was a very hard one to judge in the end. This year's category is going to be AI and its impact on building services industry. We have ARBS 2024 coming up, which is going to be in Sydney this year, so that's 28th to 30th of May. Bring together a showcase rich expertise, including CIBSE's president. So Adrian Catchpole is going to be over, and he's delivering a keynote address in the ARBS seminar series in Sydney in May. There's a couple of other noteworthy sessions that are going to be included there as well. So the Energy Efficiency Insights by Dan Bertino of the National Carbon Bank of Australia. Championing Diversity with Alison Stockland of ASBEC, BEC, and Carolyn Fitzgerald from Woolworths Group. And then we've also got the Future of Smart Buildings with Subbu Sethuvenkatraman of CSIRO and TK Wang of Virtual Buildings Information System. So you can register there at arbs.com.au. And then finally, we've got our event partner. So without having our event partners, we can't put on these technical seminars and everything like that for everyone. So we just want to thank Nexus Recruitment, who've been working with us for almost a decade now, helping us put on these technical events and various other things. They're experts within the building services industry and sustainability sector as well for recruitment. Okay, and now over to the main event. We've got Gregor Rees, who's Director and Principal Consultant for the Indoor Environment Group, Environment and Risk Management Consultancy, Opera Group. He's a qualified occupational hygienist, and his work is focused on air cleaning technologies, including UV germicidal irradiation in the healthcare sector. As part of Opera's broader service offering, is also involved in indoor air quality assessments and controlled environment testing of cabinets and HEPA filters. Gregor's on the board of the Association of Biosafety for Australia and New Zealand and represents the IHEA on the Australian Standards ME 080 committee. Over to you, Gregor.
Thanks, James. I'll try to keep this lively tonight. There'll be a little bit of sales, but it's 90% technical presentation. And James mentioned that UV is a bit niche. Well, you know, it's certainly not in the hospital sector, and you're finding UV products in just about every air cleaning product nowadays coming out. And so this will help inform any encounters you have with UV. Whatever sort. And like James mentioned, we'll do some questions at the end. Just, okay. So I'm just trying to get the controls here working, James, so that so I can advance the slides. Any clues?
You should be able to just click or press right or left on your keyboard.
Okay. Okay, it's going now. Alrighty. The title's very deliberately specific. We're talking about air and surface disinfection, and we'll talk a lot about the difference between air and surface disinfection of UV. And when we're talking about UV, I actually finished one of these presentations last year to some engineering consultants, and someone said, "What's the reference to 254?" And it was something that I was annoyed at myself, because I should have explained. You know, we're talking about the you know, below visible light, UV. We can see between 400 and 700 nanometers. That's detectable by our eyes. The UVC put out, ultraviolet light put out in the C range, put out by the lamps, typically in these air and surface disinfection, are putting out at 254. So if you hear 254, you know what we're talking about there. There are other types of UVs that are coming on the market, especially with LEDs and such. And some of the lamps we sell also are 187 nanometer, emit 187 nanometer, which is an even a shorter wavelength, more powerful wavelength. So UV, the use of UV 254 in drinking water, and just for context, it's nearly ubiquitous in the water industry. So every time you drink a bottle of water, bottled water, it's probably been UVC treated. And I don't know if any of you bushwalk, but a lot of folks now are using little portable UVC lights to disinfect their water when they're on a bushwalk and they're taking water out of a creek, putting a light in for a minute for about a litre, and it is effective. It's been shown to be effective in killing bacteria. So in a way, that's very much a proof of concept if people are doing that in the field. UVC treatment of cooling coils. So this is now surface treatment. Cooling coils aren't moving anywhere; they're static, and these are very popular in the hospital sector in Queensland. Typically hot, humid climates, and it's to get rid of biofilms and growths like these molds and bacterial growth in air handlers. And yeah, it's sort of a gateway for them because they're familiar with UVC in air handlers, and which is a type of surface disinfection, and that certainly starts them thinking about how else could UVC be used for air disinfection. And there's some really nice studies on UV on coils. This is just one paper. Will Bampfleth of ASHRAE fame was a co-author of this one. But and this is for air handlers in Singapore, so very hot, humid environment. And where UV was applied to the coils, you had a significant reduction in pressure resistance across the coil. In this particular study, I should say, face velocities increased, a much reduction in chilled water usage, and but that's quite typical for these really wet environments where you get biofilm growth on coils, and this is one of many studies that have been put out showing this. In more temperate regions, it's not as statistically significant, so no one's come out to say, oh, it's fabulous. But for example, if your building's a well accredited building, which is one of the building quality standards, if you like, very holistic building quality standards, if you have UV in front of coil, then you don't have to do a quarterly clean of your coil. And so people that are, or buildings owners that are well accredited, often do flick to UV on coil for that reason, wherever they happen to be. UV air treatment. Here's a photo of one of our installations. This is a Queensland hospital. It looks different to coil treatment, and the title is "Where's the evidence?" Because if you're putting UV on a coil, you're going to see the results in terms of no growth on a coil. If you treat UV water with UV when you're out bushwalking, and there's certainly evidence if it's not working. What the air treatment piece relies on is basically scientific studies showing the impact of UV on microorganisms and pathogens, and then a whole lot of trust, because you're saying, well, because it's very hard to measure any difference in the air that comes in before and after UV treatment. You can measure pathogen difference, but it's a very high-tech thing to do, and it's not easily done. Now, there are some studies coming out here. Here's a summary from a US hospital that put UV germicidal radiation, or UVGI, UVC, into their air handlers. And this is with hundreds of patients in different wards. So it's quite an extraordinary study from my perspective that they actually got the okay to do this. Now, all the wards were HEPA filtered, but one of the wards actually had UVGI installed, so this type of hardware, and it found a really large reduction in airborne and surface pathogen levels. There was also then that translated through to a reduction in hospital stay and a reduction in hospital charges. Now, there's not a lot of these studies out there at the moment, and the evidence is gathering. UV air treatment, your UVC air treatment, is still quite a new thing in many respects, and it's certainly been accelerated, obviously, with the COVID pandemic. So I thought it's very useful, because I'm always on the listen out to what people are saying about UV disinfection, and so these are like some of the folks that are endorsing it or recommending UVC for surface and air disinfection. And so the four purple boxes here, they're just your basic categories of air treatment, and mechanical filtration is excellent at removing particulates and removing a whole lot of pathogens in air. That's why hospitals particularly use HEPAs in a whole lot of critical care areas. UV is on its own, in its own little box, because it's sort of a unique mode of action. And then you've got other forms of electric air cleaners, and there's photocatalytic photocatalytic oxidation, which uses UV as well, ionizes plasma. A lot of things can kill pathogens in the airstream or on surfaces. So, but there's perhaps, to distinguish that group from UV group, there's perhaps not 50 or 100 years of research showing the efficacy of those products. And then, and I'll show some examples later, there's actually some just fogging or open reactive product on the market now that inject certain levels of a molecule, chemical that's biocidal, and we'll touch on that as well. But look, without going too far, this is sort of in chronological order. NIOSH, which is the US Institute of Health Safety, put out UV guidance back in 2009 because they had a terrible problem with I think it was tuberculosis in the US hospitals, and this guidance they put out was really an endorsement of upper air UV, and that was the first big sort of milestone in terms of a government endorsement and pushing of that technology in the hospital system. It actually has, it's very old technology. It's been used in the hospitals since the 50s, but it's the re-emergence of some of these diseases that got NIOSH to put out that guide. ASHRAE as well has been, and ASHRAE, of course, you'd all be familiar with that's US HVAC Association. They put out a lot of guidance, and they've put out a lot of guidance on UV specifically, and we'll touch on that as well. They do also not embrace, but do leave the door open for other electric air cleaning technologies. But they've got a lot of questions about, secondary products caused by the various electrical air cleaner technologies. I've borrowed some LinkedIn photos here. I'm sure Bill won't mind me doing this. Bill Banfleth has done a lot of work on UV. He's a proponent of UV. He's also a fairly big cheese in ASHRAE, which is, it hasn't hurt the cause of UV, certainly in the healthcare sector. He's specifically done a lot of research on coil treatment and the efficacy of coil treatment, UV on coils in HVAC systems. Lydia Morawska, she's a bit of a legend, actually. She's our Australian aerosol scientist, our leading aerosol scientist. So she's Polish Australian, got quite a strong accent, but she's a wonderful speaker. I'd recommend her. If you ever get a chance to listen to her talk, then do that. She was actually at the last ARBS and gave a presentation there where she gave a strong endorsement of UV technologies in HVAC and as a means for infection control. Lydia basically blew the whistle, along with a couple of colleagues, on COVID being airborne, not being on surfaces, and sort of being spread by airborne means. The UK National Health Service recently, last year, put out a guidance on UV use of UV products in the healthcare system, and obviously not promoting one product, but giving guidance on how to specify and install that. And last but not least, Shelley Miller, Shenna, she's another air quality scientist in the US, and she's also on the White House response to COVID, so the White House Summit on Indoor Air Quality, and has also said, made a strong endorsement for UV technology, mature technology available, can be used. So there's some multiple lines of evidence for the technology, the fact that it works and people are endorsing it. Here we go in a little bit more technical, and look, I won't go through this in great detail, but essentially all lamps supplied to the Australian market for air and surface disinfection, the ones that you use in HVAC systems, they're low pressure mercury lamps. They're all very similar physics and design. They're hot cathode filaments. I won't go into the details. The big point of difference is the sort of glass being used. But again, most of these are using pure fused quartz. And the nice thing about that 219 quartz, it doesn't allow any of the short wavelength 185 nanometer light through. It blocks that. It just lets the 254 through. And that's ideal for surface air and air disinfection. The reason why they don't want the higher 185 light coming through is that it actually generates ozone. That's why there's ozone in that second column heading. There's a third type of glass that actually is transparent to the 185. It's really effective for odor control. So it's used in waste facilities and it's used by hemp growers. But the key point of difference between the different lamps supplied to the Australian market actually is lamp life, and that's affected by a range of things. I won't even go into it, but there's a list of things that, how often you switch it on and off, and the type of gas that they use. And people would be aware you can buy Philips and Osram UV lamps as well. Just go online and off you go. But fundamentally, the life of the lamp is determined by the rate of coating loss on the electrodes. The electrode gets eroded as time goes on, and yes, you won't get in the weeds. Just as a general rule, though, and a general, this has not been empirically shown, but as a general rule, it pans out more often than not that your lamps with very high intensity at the beginning of life have a much shorter lifespan. So they drop off a cliff after about 12 months, less than 50% UVC output. The shiny blue light is still there. That's the last thing to go. So you see the shiny blue light and you're thinking, oh, I've got a UVC lamp working here. But in fact, if you actually get a meter out to measure the 254, you'll find that there's very little UVC being generated. So there's a trade-off between intensity, the amount of UVC put out at any one time, and lamp life. Okay, I'll circle back onto that theme later on. So I just want to really be very clear the difference between air and surface disinfection. That picture on the left is an installation of a UVC installed on coil. It's surface disinfection. Picture on the right is two of the Sanovox Biowalls, but basically lamps fitted perpendicular to the airstream and dosing the airstream as it moves. So they're different use cases and they have different metrics. So for surface disinfection, we measure a unit of light irradiance, how much UVC is hitting the surface or how much is emitted at a specified distance from the lamp. So the units are in microwatts per centimetre squared. That's the industry standard. And the alternative there is air disinfection, which is measured as a dose, so it's in joules. And that is in microjoules per centimetre squared. When we're sizing this up, when the industry sizes these up, these are the units we use. And of course, you can convert from watts to joules. 1 watt times a second is equivalent to 1 joule. So if you've got a little bacteria sitting there on your coil surface being irradiated with 1,000 microwatts for a second, it's been dosed with 1,000 microjoules. I know our little bug isn't a centimetre squared, but you get the idea, and that's the back of the envelope kind of conversion you can do, because very often you'll have customers asking for air disinfection on a coil installation, and we'll be circling back on that theme as well. And let's just go to primary reference sources. The Bible for air and surface disinfection by UVC is this book by Wally Kowalski, Władysław Kowalski. He's recently joined Sanovox, hence the nice picture of him in front of a Sanovox banner. But he's done, decades of research on UVC, air and surface disinfection, and he's put that in a 2009 publication. The back of the book has appendices with these tables in them, and it gives you lethal doses for various species. And here the A's, they've got Aspergillus, lots of different Aspergillus species here. The Aspergillus niger, if you're into mold, that's the big one in the mold space, and it's not one you want if you're in the indoor environment, loves water. But just check out the date for this. This is a 1929 research paper. This is how long this technology has been around. It's a very mature old technology, and there's a huge amount of data to support any calculations you do on a software saying that we will achieve an X amount of kill. So, yeah, and notice the D90 is in joules. So that's the kill dosage, if you like, for that particular species. Then we go on to ASHRAE, and these are the two ASHRAE publications that I alluded to earlier. These are really important publications, and they don't actually tell you how to size up systems in terms of dose, but they give you a very good guide, and particularly one section of the chapter 62 of the handbook, it specifically mentions that 1 microwatt per centimetre square can be effective in front of a coil face in terms of eliminating ore growth, but typically 50 to 100 is installed. And this is a Sanivox sizing software, and when we go ahead and we're targeting Aspergillus niger, it's actually one of the hardest to kill. It's a very tough little fungal spore. So we choose one of the toughest, or we choose the toughest, and then we size accordingly. And we're targeting 250 microwatts per centimetre squared on a coil face. So it's sort of 2.5 times what ASHRAE and Kowalski are recommending that you need. So and there's a sort of a safety margin there, essentially. Just to be clear, this is a coil of 250, 2,500 millimeters by 1,200 millimeters, and these are the lamp positions in front of the coil. This is what our sizing software generates. So what's interesting though is that when we're looking at specifications coming out in the marketplace, they're using much higher intensities on the coil face. This particular, I've just blotted out the company. It's not important. The company, a whole lot of businesses, consulting engineers are using DA15 as their source, and DA15, it's a wonderful document. It's an error published document. If you want to know about filters, it's fantastic. It also has a small section on UV at the back, and this particular specification says, look, we want 1225 microwatts per centimetre squared at the beginning of life, and at the end of life on the face, and at the end of life, you will have 750 microwatts at the end of 18,000 hours, which is around 2 years. And that's straight out of DA15. This is the first part of DA15. So DA15 talks about the 50 to 100 microwatts being, minimum clean surface values, and that's straight out of the ASHRAE handbook. But then the second part of DA15 then goes on, and I've copied this word for word, and I'm not going to read it out to you, but it's word for word out of one of the Australian suppliers of UVC lamps, out of their guide, which is available on Amazon, which is very helpful. But they've nominated much higher numbers, and we're scratching our heads as to why you'd want such high intensity on the coil face. But we've got theories for why, and we'll just explore quickly how we've ended up here. So yes, look, a bunch of companies doing exactly the same and using DA15, which is fair enough because it's actually one of the few reference points in the marketplace that they can pick up and insert into their specifications. Well, what are the implications for energy usage? So if we, let's say we size up one of our lamps at the end of life minimum power of 750 microwatts, happens to be 3 times higher to what we recommend as a minimum end of life. So that is 3 times the amount of energy, and it's locking in 3 times the amount of power consumption. And one of the things I think we're finding resistance for UV installations is that some owners have just looked at their power bills and have just pulled these things out because they're so expensive to run. And this sort of guidance that's out there doesn't help. We've had a chat to ERA and they are reviewing DA15, but these processes take time. They're done by committee. And yeah, in the meantime, the marketplace, well, you know, we're happy to submit a specification at those sort of DA15 rates. But we always, when we're doing a tender, we'll always give an alternative and we'll argue that the lower consumption will keep your coils clean, and we'll guarantee that. And there might be some reasons why a company might suggest higher intensities. One of them is that if you've got a really thick coil, and some hospital coils can be, you know, over 300 millimeters thick, there can be 10-layer coils, and you need higher power to get through the coil. If our approach to that is if it gets bigger than 350 millimeters in thickness, we just do both sides of the coil to guarantee that we keep that coil clean. So we get both sides with 250, which is 500 microwatts per centimetre. So you just do the maths on that. It's still a big energy saving from the minimum for the 750 for the DA15 spec. Now we're sort of going to cross over to why you might want higher intensities in the coil, and to suggest that as a building owner or as a hospital owner, someone that's decided to put UV in their air handling systems, they think, well, why don't I do it on the coil and achieve air cleaning at the same time? And that's sort of achieving, you know, the killing of two birds with one stone. And in fact, ASHRAE gives some guidance around doing this, and specifically for COVID-19, 99% inactivation, you need 1500 microjoules dose, and you can do the back of the envelope math on that. So the airstream must be slower than 2.5 meters a second, which most air handlers are moving less than that, and you need an irradiance zone of 2 feet or 600 millimeters. And so you get a minimum exposure time of a quarter of a second. Yeah, and if you do the math on that to get 99% inactivation of COVID, you'd have to have, I've just done the math there and I won't go through it, but you need 6,500 microwatts per centimetre squared on that coil, which is now, it's more than 10 times, near probably 15 times what we recommend to put on a coil. But here the customer is asking for air disinfection. So you think, well, okay, let's put high power on coil and achieve some degree of air disinfection. We don't do that, and we don't recommend it. We'll certainly submit a tender, and you know, we sell more hardware. We don't like it. We think it's bad engineering, and that's essentially because most HVAC systems, and you guys can correct me if I'm wrong. You know, this is your territory, but they sort of operate around 13 degrees Celsius, and low pressure mercury lamps, which are supplied on the market for surface and air disinfection, they don't like cold conditions. They actually don't like being in front of a coil, certainly not a naked lamp. And there's a real wind chill effect. And if you're running your air handler at sort of 13 degrees Celsius, you're actually, the UVC output, it'll still suck all the power that it always does, but it will not give you the UVC output of something operating at 21 degrees Celsius. It halves. In fact, Sanovox actually recommends for coils, you place the UV insulation upstream. The best practice is placing the UVC insulation upstream. We need far fewer lamps and you use far less power, and the UVC still goes through the coil, so you don't put it downstream of the coil. Now, most customers want it downstream of the coil because you've got the tray there, you've got the water accumulating there, and that is also irradiated and stays clean. So a point of difference in terms of the Sanovox product, they always sell the product or the coil cleaning with with a parabolic reflector. It's made out of brushed aluminium, reflects most of the light, like 80% of the light, back towards the coil. Again, if you think about a lamp, the front of the lamp sitting in front of a, imagine jumping into a air handler downstream of a cooling coil with glasses on. It gets fogged up very quickly. The reflector is really important to make sure the energy goes forward and disinfects the coil. So the Sanivox approach to air cleaning is not to put a huge amount of energy perpendicular to the airstream in front of a coil. They go parallel with the airstream, and this is their Biowall product, runs parallel with the duct system, which also maximizes the time that you have exposure of air, depending on the speed through the duct, which we calculate, and maximizes the time for air exposure coming through the duct. I'll just play a video here just to show you what the installation looks like. Yeah, sorry for the funky music. Anyway, back to regular programming. And you can see from that video that there was a single Biowall for a smaller duct. Then if you get really big ducts with huge amounts of moving air, we go to a double Biowall, and they come in different lengths. So and it's all about dose and exposure time. And look, we've done comparisons of parallel versus perpendicular installations to achieve an air cleaning outcome, and essentially by going in front of a coil, and this is a separate issue to the DA15, let's triple the power, but if you just go for like air disinfection in front of a coil versus a Biowall, it's just locking in 2.5 times energy consumption. So there's some just significant dollars being locked in if people are seeking to go down that route, which is why we give them the maths and we show them that you'll save money over the installation period, over a 5-year period or 10-year period easily on a Biowall installation. But look, the last, this is a bit more prosaic, last reason why you might wish to have higher intensities on the coil is you sell more lamps. So the Sanivox lamp, it has about a 25%, we talked about lamp life earlier, Sanivox has about a 25% decline over a 2-year period, 17,000 hour period. Whereas the competition, if I can say that loosely, it actually declines by over 50% over 1 year, a typical lamp, and that also includes the Philips and the Osrams and those sort of. The reason why they're quite coy in their literature about lamp life is because it basically doesn't last very long, and if you switch it on and off a lot, then yeah, even less. So over a typical installation, and I'm pointing to the right picture here, this is a DA15 intensity installation, a typical installation using far more lamps than we would suggest for a coil. But that installation is using 4 times the number of lamps as one of our installations. So yeah, sorry about the marketing look, but just to wrap it up in terms of the technical piece, the UV surface and air disinfection, they're very different things. They're using different hardware and different metrics. And someone's selling you something that does the 2 birds with 1 stone, that comes with a really big cost in terms of the cost to your customer, just in terms of electricity consumption. Air disinfection in front of coil, it's a 2.5 time, sort of key takeaway, 2.5 time the amount of power of an equivalent disinfection that would occur in a duct installation. We call it bad engineering. We don't like it. And UV lamps, just in terms of, we've had some customers want to compare lamps by the initial irradiance of the UV lamp. And what I said earlier about, irradiance, the very hot lamps having short lives, the Sanovox lamps don't generate as much irradiance as some of the competition, but they've got much longer lives. So you're going in there every 2 years, where there's a 25% decline instead of replacing lamps every year with a 50% decline. I've just got a couple more slides that I'll show you, and this is a bit of fun, really. And now we're going to sort of just branch or look at some installations, and we'll also look at some of the other sort of UV-ish products that are on the market. And we're agnostic in terms of 254. If something comes on the market, if someone generates an LED with a UV emission in the 270 band around there, long-lasting LED, 270 nanometers, and that doesn't use 10 or 20 times the power of the low-pressure mercury lamps, we're onto it, and Sanovox will be onto it too. But look, these are just an example of some installations of UV showing the standard of some of these. The one on the left showing a lamp sitting in a duct. I think the customer was told that this would be a form of air disinfection. It may have achieved something, but I'm not sure what. The middle photo is another, same hospital actually, but the lamp's been used as a structural member to support the other UV lamp. The photo on the right, I took the photo on the right. That's a hospital in New South Wales, and that has an unshielded UV upstream of the cooling coil. So yeah, fantastic, good installation in terms of keeping the coil clean and the back of the coil remain clean. Unfortunately, those filters were destroyed, and they were F8 rigid V panel filters, and they were just falling to pieces. I wasn't sure how long they'd been in there, but example of probably a poor installation. So the quality of installations vary, and be careful. The other part about the unshielded, I touched on the parabolic mirrors earlier. If you have an unshielded UV in an air handler, it will affect anything that's plastic, so that the power line to this particular fan motor, it will be destroyed eventually. It'll get brittle and fall apart. Also, the damage to the powder coating is quite noticeable in this particular installation. So again, if you have, and it makes sense, doesn't it? If you have a parabolic mirror shining the power forward, all the power is going, or the UV energy is going onto the coil. It's not going through to the rest of the air handler. Some people argue that, this is good because it stops mold growth in the air handler in general, but then you've got an issue with the design of your air handler if you've got general mold growth in the air handler and the ducts downstream of a cooling coil, where you should have some degree of humidity control. Buyer beware, part 3, the non-254 nanometer lighting products. So this little diagram out of the ASHRAE handbook shows the germicidal efficacy of UVC. So it basically ends at about 320, which is still below I think that's a UVB or something, but basically it's not very effective in killing microbes at 320, and it drops below 240 or down to 220. It really drops off a cliff in terms of germicidal efficacy. The little orange line there just shows you where the 254 sits. And I mentioned earlier, if we can get an LED that produces at the 270, the top of the curve there, we'll have a really powerful tool. But this is a product put out by a company that imports surgical suites into hospitals, and they have an LED light product of 405 nanometers. And we had a look at this, and it is 30,000 times less effective in killing pathogens than 254. And if you want to use a light to decontaminate a space, don't use a 405 LED light product, because it's just pretty impractical. But it's UV-ish. You see what's going on here? So it's a light that disinfects. Similarly, okay, we've got some 222 nanometer products. So this is coming down to the bottom left-hand side of our curve here. They're called Krypton chlorine excimer lamps. They actually can go online and buy them online now. This is quite unregulated, this light market, and they're recommended for occupied areas. So this is a I don't know if it's an LED as such. I don't know what a krypton chlorine excimer actually is technically, but it does emit a 222 nanometer light. And it is more effective than the 405. It's 8 times less effective than 254. So, and it turns out that it does generate a whole lot of secondary aerosols in rooms. And this research is just coming out. I've referenced here a YouTube clip, but the first papers are coming out to say, hey, by the way, if you use this in occupied rooms, there's a bunch of secondary aerosols created by the 222 for a start, ozone generation, but then a whole lot of other things. The 222 also, and this is very interesting, it's a higher power wavelength than the 258 or 254, sorry, but it doesn't penetrate the skin very far. So no one's had any skin or eye damage by being in a room with these light products, but we still more research needed really on some of this stuff. By wherefore, there's now, remember our last box earlier on where we had fogging products? There's now a couple of products I'll show you here that are designed to be used in occupied spaces, and they inject various molecules into that occupied space. This one uses a UV light to generate not ozone but hydrogen peroxide using a catalyst, and you end up with a very low dose of hydrogen peroxide in an occupied space, much lower than the exposure standard. So the exposure standard, this is 1,000 parts per million. Hydrogen peroxide, you know, it's got a half-life of about an hour, and yeah, I mean, we use it to fumigate laboratories, hydrogen peroxide, at much higher levels, at 800 parts per million. But at 1 part per million, you probably won't notice it. But you know, I mean, there is a question around placing a novel molecule, even though it does occur in nature, but a novel molecule into the breathing space of people to kill potential pathogens. And I've just highlighted ozone here because there was a bit of a move to pump ozone into occupied spaces to control airborne pathogens as well. But that's certainly gone out of favour, and ASHRAE say no ozone, zero tolerance, and ozone's a lot more active than hydrogen peroxide, or a lot more, has a much lower exposure standard. Here's another one. This one uses hydroxyl radicals. So it's like a water molecule with a hydrogen missing. They've got a much lower, much shorter half-life. There's no exposure standard for hydroxyls. But this particular product, I'm sorry I mentioned the company name. Yeah, look, I mean, they're good luck to them. But it's another product essentially fumigating an area, but at very low concentration. And by doing so, potentially killing pathogens, airborne pathogens. Certainly, hydroxyls are being used in the restoration industry, and it's replacing ozone. It's a safer product there. Okay, just nearly wrapped up here. When you're looking for these products, any products to go on a HVAC system, check the Australian registration RCM first, and that's easy to do. And this is my sales slide. Forgive me, but our points of difference with Sanovox engineered solutions. We're very concerned about power efficiency, and that goes with engineering outcomes. And we think you should look at the total loss cost of an installation, and not just the initial costs. Obviously, prices vary significantly. I've put those other two pictures in there just to indicate that Sanovox does a bunch of other products. The one in the middle is one of their air cleaners with a filter. The one on the left is a wall hardening air cleaner, both with UV. using 254. And for example, I know in Victoria at the moment, upper air UV is all the fashion. I think that's been mandated by the government there. I could be corrected, but we think these products are far better. The one on the left actually fits in a ceiling tile and does the same job as upper air UV without the risk of people standing on a chair and looking into a blue light. Yeah, there's some references there, and that's me. You'll find me on LinkedIn and contact details on there. Thank you very much.
Sorry, I was muted.
Hey, James, welcome back.
Thanks for that. That was excellent. We've got quite a few questions if you've got a few minutes. It looks, well, I think a couple of them have been answered as you've gone through, but I'll read them out anyway. So Simon Agostini has asked, do you recommend coil treatment upstream or downstream of the coil? I think I know the answer to that one.
Yeah, I mean, I'll also elaborate on that. When you think of an upstream installation, there is a possibility that you won't get UV in the tray, the water tray, the capture tray that you would get on the downstream side. It's about a 20 to 30% power saving to go upstream. That's why we like it. We think if you do it well like that, you won't have any mold growth issues in your tray, because basically that whole coil face is not a reservoir of microbes and molds that will grow in the tray. So, that's our rationale for it. But 9 customers out of 10 want it downstream, and that seems to be the norm here.
Simon's also asked, we have a client who has a lot of issues with mold in the ductwork of his AC systems. Is the application or air treatment UV a solution to deal with mold in the downstream ductwork?
Now, this is a really good question. And basically, no, the UV is one tool. It'll keep your coil clean. It can't treat downstream. If you've got a client with mold growth in ducts, that has to be physically cleaned by a contractor. There are people that do this for a living. Apera does it in Queensland. They have a company called Aerostore that does. They're probably one of the bigger Queensland duct cleaning companies. Yeah. So no. And if someone's promising you that you'll keep your downstream free from mold, I mean, the dust, UV does nothing for dust, does nothing for particulates. You have to have your filters working. And we constantly emphasise to customers that you make sure your filters are at a good standard. Otherwise, your UV is starting to fight a bit of an uphill battle. Yeah, and it can't. Obviously, UV. We had a customer that wanted to shine UV light in the entire downstream air handler to stop mold, and then that comes to a question of why is mold growing in your air handler in that way? That's not normal. That's something about the design of the HVAC and your capacity to control humidity. Yeah,
makes sense. Guess everyone's just looking for that silver bullet, aren't they? Gary Linger has asked, what is the monitoring technology to ensure that UVC lamps are effectively operating? Or is it a simple matter of replacing on duration? Yeah,
the Sanovox software is based on time. It's not based on emissions. So when there can be a failure in the lamp, which it must detect something electrical and say, no, you got an error, light turns on. Otherwise, it'll just turn on to amber when it's done 18,000 or 17,000 hours. We do measure UV with NADA calibrated instrumentation. So I do jump into air handlers for clients and do a measurement of UV on their installations. It's very hard to we haven't found any equipment that you can permanently install. Like let's say one of our handheld UV meters, they actually get damaged by the UV light. So if you have a constant monitor using one of those pieces of equipment, eventually it just degrades and stops. The UV light damages the sensor in effect. So yeah, we don't have a solution there. Our software and our hardware is based on time a lamp's been operating.
Makes sense. Simon's asked, filters can't be treated with UV, is that correct?
Oh, they certainly can. I mean, in fact, there's a number of air cleaning products, portable air cleaning products that have little weak UV lamps in them that actually kill. So this is specifically designed for hospital air cleaning. And you've got a HEPA filter, and it's got a weak little lamp there that's killing any pathogen that lands on the HEPA filter. It's quite a nice design. There's a couple of those on the marketplace. Now that's using a weak UV. If you start hitting a filter with anything like the intensity of on a coil, the filter just they're typically made out of petrochemical products, and they just fall to pieces. They just fall apart. I've seen them fall apart, and I have actually asked a couple of our suppliers for recommendations for UV resistant filters, and they couldn't recommend anything really. So yeah, shield your UV from your filters. Otherwise, you'll be buying
from
new
anything
filters.
Organic, really, isn't it?
Basically, yeah. Even I mean, I don't know what the paint is in powder coating, but it doesn't like it either. So yeah, shielding's really important so that the energy goes on coil. And I mean, look, I was speaking to one of the companies in Sydney that does coatings on coils to stop deterioration and rusting of coil. And they're all organic coatings too, and so they're incompatible with UV as well. And we're having a laugh about the fact that my product destroys his product, but I was arguing perhaps that wouldn't need his product if the coil was kept clean. So yeah, anyway, more research needed.
One thing that we came across when we were looking at UV in air handling systems, and I don't believe you touched on it at all, was interlocking and warnings. So
yeah,
obviously you've got that low sort of bluish light that comes with the mercury vapor lamps as somewhat of a warning, and that people can see that something's there. Do you have anything to say about sort of those either mechanical or electrical interlocks, or whether or not that just be warning signage, or what do you typically see there?
Yeah. And I do have a whole separate presentation I've done on UV safety because it will damage skin, it will damage eyes, and I've spoken to HVAC contractors that have jumped into air handlers and been told, oh no, that's fine, it won't harm you, and they're having symptoms of snow blindness on the way home. We won't sell a system without interlocks, and we actually don't sell systems without the windows either. We insist on the visual cue. So door interlocks. Now, when I jump into air handlers, I use one of those Tyvek suits, just cover all my skin, and then basically use a plastic shield and a pair of backup goggles, because UV is very bad at penetrating through materials. It gets absorbed very quickly. So and that's why at 222 it basically doesn't really damage your skin anymore. So strongly recommend if you do have a system without any of those interlocks, just retrofit them. It's easy. And the window, the plastic polycarbonate windows are very easy to install as well. So yeah.
Jerry has his hand up, or their hand up.
Oh, yep. Hi, Gregor. By the way, just
G'day.
Great presentation. Thanks for that. I just had 2 questions, if that was all right.
Shoot.
Yep, cool. So one of them was, I guess, based on what we've just kind of saw, it seems like, I guess, UV is great when it comes to, let's say, trying to reduce, say, operating costs or even just carbon emissions due to, I suppose, maybe less maintenance, less filters potentially, and things such as that, like these kinds of benefits. And I was just wondering, would you happen to know if whether that be Cenovox, sorry, or any other supplier, would they typically maybe provide EPDs for this type of equipment, or like environmental product declarations? Just given that, as James mentioned at the beginning, I was actually one of the aforementioned people who was involved in the SIPSI kind of young engineers workforce. And there was a huge focus on embodied carbon last year. And I guess I feel like with a lot of engineers who sort of go for, let's say, maybe a Green Star or NABERS rating, they might get those credits for operational carbon reductions. But when it comes to embodied, like the upfront or the end of life or maybe even replacement sort of emissions, that could sometimes be where they get sort of tripped up.
I won't answer the EPD piece. I don't know. Look, Cenovox, it's been around since 1996, and the argument for the UV is based on more health outcomes rather than environmental benefits, if I can put it that way. So the focus has been on ensuring you don't have a mold delivery. Your HVAC system's not a mold delivery system to the building, and your sort of sick building. Yeah, I'm sure I'll have to take that on notice and come back to you, Jerry, in terms of like Green Star ratings, that sort of thing. We do provide a calculator for coil installations that allows you to calculate energy savings associated with the lack of biofilm growth on your coil. And it takes into account the the energy usage of the lamps and the system, and then, I mean, look, it's overwhelming for anything north of Lismore. It's overwhelming evidence to say that this is a really smart idea for energy saving. And in terms of the sort of NABERS, I did mention WELL earlier. The WELL's the interesting one. They're a very progressive standard. They do allow you to either install UV on coil, or you go and clean those coils every quarter. And I think the cost of cleaning every quarter is more than offset by the saving on the UV installation, if that makes sense. So that's just labour cost, physical cleaning of the coil. You don't basically have to clean those coils after UV has been installed. So I hope that's answered your first question adequately, Jerry.
Oh, yeah, no, that was very informative. Informative. Thank you for that. I guess my second question was, when it comes to UVC in particular, especially, let's say, the higher your, I guess, your dosage or your, I guess, what was the other one? The micro watts per centimeter squared.
That's the unit. Yeah, that's right.
Yeah. So the higher that is, especially, or maybe even like the smaller the kind of wavelength of the UV, when it comes to, let's say, the its effect on coils in potentially more corrosive environments, where, let's say, it's nearer to the sea, or have you ever come across situations where maybe it starts affecting, let's say, the epoxy resins on the coils or anything like that?
It'll destroy your epoxy resins, Jerry. That's exactly what. And even a low power, given enough time, will remove your epoxy resins, because your epoxy resins are made from organics, and they're susceptible to UV. So I don't know what the outcome would be. We encourage customers, and we sometimes offer really like for trials like this. If you had a customer with an installation close to the coastline, and they're willing to compare what happens to their air handlers, and they've got equivalent air handlers, it would be a really interesting trial to run. But your epoxy won't be there, therefore it might be attacked by seawater, therefore you might have more corrosion.
Gotcha. Okay. Thank you so much.
By the way, Jerry, the higher power doesn't affect the wavelength. It just means that there's just way more 254 on the face, but it's all the same wavelength.
Gotcha. Cool.
I unless there's any other questions, I was going to ask you quickly about you mentioned the Victorian government may have, you say mandated upper room, sorry?
There's a tender out at the moment for upper air UV. And it's I believe it's a government tender. And I think it's on the back of the fact that NIOSH put out a guide on upper air UV in hospitals. And this is essentially putting, a piece of equipment up there that shines light into the ceiling space. I mean, look, to be fair, there's companies like Philips that have product, off-the-shelf product you can purchase, and we probably aren't competing against Philips in that space. But I mean, we don't like it as a solution. It's quite an odd solution. I mean, that's what they were doing in the 1950s to control tuberculosis in hospitals. Yeah. And we think times have moved on and we've got better ways of doing it. But
vaccinations.
Yeah. Well, no, I mean, we're on board with the UV. I think that's actually upper air UV is quite effective. And if you have circulation in a room, you're killing pathogens like in that space. Let's say it's a reception area in an emergency ward in hospital or something like that. We like to enclose our UV in containers where you can't poke your head up and have a look at the UV light or wonder what that blue light is over there. We don't. Yeah. Look, it doesn't reflect off other surfaces. It's of course safe. There's a guideline out for it. It's just not a product that Sanovox promote. We have alternative systems like the one that fits into the ceiling tiles and runs air through a UV lamp, enclosed UV lamp.
I've also seen some of the LEDs that they're producing with 222, 254, and I think 275 nanometer.
Yeah.
And adding a little blue LED chip to it as well, so it looks like UV.
Well, look, it's interesting. The low pressure mercury lamp. You think about that thing, and it's old technology. It's been around since the 40s. And luckily it gives off a blue light because we can't see UV. If someone invents an LED that emits a UV without any visual cue that we can see in our range, you might get a lot of damage. What our experience with LEDs have been to date is that they have a really enormous power consumption. So for every wattage used by a low pressure mercury lamp, about 33% is converted to UVC. The best the LEDs have been doing is like 5%. So they're using multiple times the amount of energy to produce the same UVC. I'm sure there will come a replacement of low pressure mercury lamp, but at the moment that's the best technology available for surface and air. And the 222. Oh, gee whiz. I mean, there's just so much more work to be done in terms of the secondary health effects of exposure and aerosol generation. And it's always a surprise to me to go online and see this stuff available for purchase by Australian consumers. You can go and purchase a nice, and I've done this, a Philips UV bulb. They're manufactured in Poland. They're sold online by suppliers here in Australia. Doesn't come with any warning label. It fits into your domestic fluorescent fitting, 2-pin, just fits into your domestic fitting and turns on. It's fabulous. You can, give yourself a much needed dose of UVC.
And yet they banned tanning beds. Yeah.
Well, yeah, that's another issue. I can't really comment on that. But look, UVC. If you were on a tanning bed with UVC lamps, that would be very bad. Yeah.
Yep.
And only to be used in discos. Apparently, this has happened. One of the suppliers in Australia had UVC lamps installed in a nightclub because of a lovely blue light. Yeah. So it's
wow.
Secondhand story, but you can imagine it happening given that it fits in domestic fittings.
Dangerous.
Yeah.
We've got a couple more questions and then we might wrap it up.
Okay.
What are the lamp replacement costs for an average AHU?
Oh, it's there, got me there. I mean, in terms of percentage of your original installation cost, it might be 20%, but it depends on the size of the system, so, and the bulbs. Yeah. I mean, yeah, very difficult question to ask over this video call.
Fair enough. And what is the average lifespan of lamps in 24/7 operation?
So a Sanovox, you'll get 17,000 hours where you'll lose a quarter of the power output. You can actually extend that to 25,000 hours, which is 3 years full time, 24/7. I think my maths are right. And it'll still be emitting more than 50% of its original power output. But other lamps, the DA15 specification is representative of 12-month lifespan of some of our competitors, and that's dropping from 1,200 microwatts to the 700. So nearly halving in 12 months. That's quite typical of other lamps.
Yeah. All right. Unless there's any other questions, we might call it a day there. Thank you again. That was very informative, very in depth.
Kept you awake. Thanks everyone for giving me the opportunity to talk. I really enjoy that presentation.